Hello and welcome to Chapter 4, Section 8, Similar Figures. Now, you've been working with standard measurements and you've been working with metric measurements, and you now know how to convert the two. Now we need to pull the whole idea of proportions, which is what this whole chapter is about, pull proportions into all of the measurements that we've been working with. And that involves a little bit of geometry. So, we're going to define some terms first. The word similar means it's the same shape, but it's not the same size. So this is taking a shape and exactly, proportionally, making it bigger or smaller. Now, you've got corresponding angles, which means the angles of the two similar shapes that are in the same relative position. For example, angle A and angle D are corresponding angles. So are angle B and E, get it? And corresponding sides is the same definition, but with sides. So side AB and side DE are corresponding sides. That kind of thing. You good with that? So triangle ABC is said to be similar to triangle DEF. Now, there are a couple of things that I need you to understand about similar figures. Their angles are always exactly identical, and their sides are proportional. And we should probably write that down. Angles are the same, and sides are proportional. Write that down, please. Now, let's say we have 21 centimeters and 36 centimeters and 24 centimeters. And this 7 centimeters and 12 centimeters and 8 centimeters. So the question is, are these two similar? And what you need to do is set up ratios, proportions for all the sides. Okay? So here we want to set up so that triangle ABC is on the top and triangle DEF is on the bottom. And it doesn't matter which one is which. What matters is that you keep it consistent throughout. So we want to see is 21, and this corresponds to this, over 7, equal to 36 over 12 and equal to 24 over 8. Now, each of these are corresponding sides, and ABC is always on the top and DEF is always on the bottom. If you don't set it up that way, it does not work. Now, we need to do some quick, well, these we can reduce. We can actually reduce these. I know that I can divide each side by 7. Divide this by 7, divide that by 7, I get 3 over 1. Divide this by 12, divide this by 12, I get 3 over 1. Divide this by 8, divide this by 8, I get 3 over 1. So they all reduce to the same fraction. That means they are proportionally equal. That means they are similar triangles. Now this works with any shape. All of the angles are identical. So you're actually going to see this. You're going to see that this is a 70-degree angle and this is a 30-degree angle, which makes this an 80-degree angle. And if this is a 90-degree angle, you know they're not similar because the angles have to be identical. So if you know that this one's 80, then you also know that that one's 80, and this one is 70, and this one is 30. Okay? If they're not the same, then they're not the same shape. And they have to be the same shape in order to be similar. All right. Can you do it backwards? Now, I can tell you that they're similar and then give you the numbers. Here I'm saying, I'm giving you the numbers and I'm saying, are they similar? So, for example, I've got a rectangle here that's 10 centimeters long and 5 centimeters wide, and I'm telling you that all of the angles are 90 degrees. This little square in here, this means that this is 90 degrees. This is shorthand for actually writing that out. It means this is absolutely square. And if this one is square, then you can assume, unless they tell you otherwise, you can assume that all of the other ones are square as well. Okay? Now, so I'm asking if these are similar or not. So we're going to make a set of proportions where I've got length over height here, and I've got length over height here. And I can tell you that this reduces down to 2 over 1, and this reduces down to 2 over 1. So these two shapes are similar. Now, is this shape similar to this shape? Because I can tell the same thing. I can say this is 10 over 5, this is 8 over 4. Check it out. These two are similar. But what's the difference between this one? This one does not have the 90-degree angles. This is actually a parallelogram. It's shifted slightly to the side here. So in order to be similar, you have to have two things. You have to have proportional sides and you have to have exact angles. Okay? Now, it's not always obvious. Okay? I use something that reduces down to 2 over 1. But sometimes you get something like, sometimes you get numbers like this. What if this was, let's see, 7, and this is, no. What if this is 7, and this is 10.5, and this is 11, and this is 15.5. They're not always going to be perfectly fractional, and you can't just reduce. Sometimes you're actually going to have to do the cross multiplication solving for proportions. So in this case, you want to, again, it doesn't matter what, but you have to be consistent. So I'm going to say length over width. So I'm going to say 15.5 over 11. Does it equal 10.5 over 7? Now, are these proportional? Well, now I have to do 15.5 times 7 equals 10.5 times 11. And now I've actually got to do that math. And 15.5 times 7... and 10.5 times 11. And I can tell you, no, these two are not proportional because the cross multiplication doesn't work. Okay? What if you get shapes that aren't shapes that you're familiar with? What if you get irregular shapes? Here, I've got two trapezoids. Okay? First thing I'm going to check is, do they have the same angle measurements? I've got two 90-degree angles. I've got 135 and I've got a 45. So far, yes, they look to be similar. But now it's not just doing two numbers. I've got to do all four of these numbers. Now, the first thing I'm going to do is notice, oh, this one and this one are the same. This one and this one are the same. So I don't have to do this twice. I only have to do it once. So I'm going to have 10 over 4 as one of my ratios. Then I'm going to take the long diagonal. 15 over 7.5 and 20 over 8. They all have to match up if these are going to be similar. You can't just take randomly two. So 10 over 4. So we've got these three. And the question is, can I reduce them down to the same fraction? Now, I can do this one of two ways. I can find one common denominator. And my common denominator, let's see, 7.5 times 2 is 15. So my common denominator for 4 and 15 and 8, 8 and 15, 8 and 3 and 5 is 40 times 3 is 120. So I can go to 120 on all of these and find my common denominators, or I can see if they will reduce all to the same fraction. If I reduce this, this becomes 5 over 2. 2 goes into 2, 2 goes into 10. 2 goes into 10. 4 goes into 20 5 times. 4 goes into 5 2 times. So these two make it look like these are similar. Can I get 15 over 7.5 to equal 5 over 2? Well, this divided by 3 is 5, so this divided by 3. If this divided by 3 equaled 2, yes, that would be perfect. However, this would have to be 6 divided by 3 to equal 2, which means this does not make it proportional. 15. So that makes this line and this line not similar. So if any of your lines don't work, you have to say not similar. Okay? Your turn. You've got 2 to work here that I'm about to work with you. Let me read these to you if you can't see them. I have triangle A, B, C here. I have triangle D, E, F here. They have angle measurements of 30, 46, and 104. 30, 46, and 104. I have side measurements of 9 meters, 12 meters, 6 meters, 3 meters, 4 meters, 2 meters. Number 2, I've got 2 trapezoids. Angle measurements 40, 140, 90, 90. 40, 140, 90, 90. I've got 5, 7, 3.5, and 11 centimeters. I've got 5, 11, 3.5, and 15 centimeters. So your job is to figure out, are they similar or not? Push pause and come back when you're done. Okay. First off, they all have the same angle measurements, so we're good with that. So now, we're going to do 9 to 3, 12 to 4, 6 to 2. So now we're going to see if they can reduce down to the same thing. I can divide this by 2, and I can get 3 over 1. 4 divided by 4, 12 divided by 4, I can get 3 over 1. I can also divide each of these by 3's, and I get 3 over 1. So this is similar. And then I get over to this one. And this one, realize I've got to turn it this way in order to find my corresponding lines. So I've got 5 to 5. I've got, I'm going to go this one to this one. 7 is the top one, and 11. 7 to 11. And 3.5 to 3.5. And the bottom is 11 to 15. So this reduces to 1 over 1, and this reduces to 1 over 1. But this doesn't, and this doesn't. And because they don't reduce to the same thing, they are not similar. All right, your job is to work that out for numbers 3, 4, and 5. And again, if you can't see them, I've got 40, 70, 70, 48, 48, 28. I've got 34, 73, 73, 18, 18, 12. For number 4, I have 2 rectangles with 90-degree angles, 14 by 49 and 10 by 70. And then number 5, I have 2 triangles. I've got 38, 60, 82 with 34, 24, 30. I've got 30, 60, 82 with 60, 40, 50. All right? Work that out. Bring that in. Put your turn in a cloud, please, so I can tell the difference. I am looking for hazard signs. I am looking for questions. And I am looking to see, with a star, what you think is, you know well. Okay? And I will see you tomorrow. Good luck.